Okay, this video goes over the normal distribution homework solutions. First problem, they give you the mean and the standard deviation to be 30 and 5, and they want you to determine what the z-score is given an x value. So they give you these numbers, and they want you to determine the z-score. The z-score formula is always equal to x minus the mean divided by the standard deviation. So if that's true, to calculate a z-score when x is equal to 25, I reference that cell minus the mean in parentheses divided by the standard deviation, and I put dollar signs around my references to my mean and standard deviation. Copy those down. That's the answers. For problem 621, I'm not going to grade because I didn't go over the notation, but when you see notation like this, what they're looking for is what is the z such that the area to the right is 0.01. What is the z such the area to the right is 0.05. What is the z such the area to the right is 0.02. And then on these, what this is what is the z such the area to the left is 0.01. What is the z such that the area to the left is 0.05. So this is, to solve for these bottom ones are actually the easy ones. How we solve for those, you can use the norm INV function, and you put in the area to the left, which is 0.01, and then the standard normal, because it's a z-score, the standard normal, the mean's always 0, and the standard deviation is always 1. So that's an easy one. This one is, the area is 0.05. This one, the area is 0.1. These are trickier because they want the area, they want the z such that the area to the right is 0.01. That's what that represents. Well, the norm INV function doesn't give you the area. It wants the area to the left. So look what I did. To solve for this first one, if the area to the right is 0.01, then the area to the left is 0.99. So the first argument is 1 minus 0.01, where the 0.01 is this value, and then the mean and the standard deviation. So z such that the area to the right of that is 0.01. Z such that the area to the right is 0.05, as I put in 1 minus 0.05 to come up with this, and then z such that the area to the right is 0.02, you put in 0.98, or 1 minus 0.02 in the area, and that gives you those numbers. 625 we did in class. The mean and the standard deviation, what are the chances that demand is going to be less than 0.959? That's just a norm dist problem. When it's solving for a probability, use the norm dist formula. When it's solving for an area to the right, you got to do 1 minus. Area to the right, 1 minus. When you're solving for less than that or that, add them up. Area to the left is 650, you put in 650, that's what this first half does. This finds the area to the left of 650. The area to the right of 950 is this part of it. That's the area to the right of 950, add those up. So I added them up. Problem 626, they give you the mean and the standard deviation of 0.5. They want to find the area between 7 and 9. This is the formula to do it. I'm not referencing the mean and the standard deviation like I should, but that's the formula to do it. The area between is take the area to the left of 9 and subtract the little area to the left of 7. And you do that for all three of those. Something like that. And then you just change the numbers. This one is between 9.5 and 8.5. This one's between 7.5 and 6.5. So these are just numbers. Then the area to the right of 8, probability that you would get a number bigger than 8. It's 1 minus norm dist 8, but 8's the middle, so it's 50%. Less than 0.7, you just use the norm dist. And the area to the right of 7, you say 1 minus that, or you area to the left of 7. All right, so that's that one. 630 we did in class. If the mean of these tires is 40,000 miles with a standard deviation of 4,000, what should the mileage be that if someone comes in and says, hey, my tire failed at this mileage or less, that they would get a a warranty. They would get a free tires or their money back. They only want to have that happen 2% of the time. So I use the norm INV function and put in 0.02 because that's only going to happen at that value or less. So if the tire has 31,785 or less and fails, which is only going to happen 2% of the time because that's what the norm INV function tells me, they'll have to give their money back because they have a guarantee. Problem 634, it's exactly like this problem. We know that the healthcare cost for someone averages $3,000 per year with a standard deviation of $500, and it's normally distributed. The insurance company wants to offer a premium reduction. They want to be able to offer a premium deduction, but only if their healthcare cost is low. And so it only is going to occur if it happens, we only want it to happen 33% of the time. So what expenses that if it's less than that, they'll get a deduction in their premium going forward? Well, that's using the norm INV function. And we put in 0.33 because it only happens 33% of the time or less. That way, if someone's healthcare cost, are $2,780.04 or less, the next year we'll offer them a premium. We don't want to offer this to very many, only 33%. Okay, that's the homework.